Welcome to section 9.3. In this section, we're going to solve absolute value inequalities. Those are inequalities that look like this. They involve both absolute value signs and inequalities instead of equalities. So you might have a less than or a greater than sign involved in the equation. Okay, this first one we're going to do by drawing a picture to figure out this inequality. This says solve the equation the absolute value of x is less than or equal to 2. Now remember, absolute value means distance from 0. So this means find all the numbers x whose distance from 0 is less than or equal to 2. Okay, let's draw this on a number line. So we'll put 0 in the middle here because we're interested in distance from 0. Now you could go 2 units to the right. That would put you 2 units away from 0. Or you could go 2 units to the left, which is also 2 units away from 0. Now we're looking for all the numbers that are less than or equal to 2 units away from 0. So any number within this range, right here from -2 up to 2, including those two numbers are 2 units away from 0, or any of these numbers in between, right, have a distance from 0 that is less than 2. So all of these numbers in between, and including -2 and 2, will satisfy this inequality. Therefore, the two ways to write the solution to this inequality are in interval notation. You could say from -2 to 2, or I'm going to skip set builder notation for now and just write it as an inequality. You could also say x is between -2 and 2 like this. Okay, I'm going to stick with this notation because it's going to actually help us to solve these equations. Okay, now from this we can extrapolate a method for solving absolute value equations that involve a less than or equal to sign with the absolute value on the right. In other words, where the absolute value is less than a number. Less than or equal to. Okay, and here it is right here. If a is some positive number, such as in this case 2, then the absolute value of x is less than an a is equivalent to saying that the negative of a is less than x is less than a. Now if you look, that's exactly what we wrote right here, where a is equivalent to 2, so we have a -2, negative a, 2 and a, and then in the middle you have what is inside the absolute value bars, which is in this case x, so therefore x is in the middle. Okay, so when solving an equation like this, you take what's in the absolute value bars, that goes in the middle, and then what's on the other side, as long as it's a number, goes here and here. On the right side it's positive, on the left side it's negative. Okay, let's do an example. Oh, and of course this is true whether it says less than or less than or equal to. It just depends on what's given in the inequality. Now this one's a little bit harder to figure out just by looking at because you have a b plus 1 in the inside of the absolute value bars. So to solve it, it's a little bit trickier, but we can use this method that we discovered up here. We have the absolute value of something is less than a number. Therefore that's equivalent to saying this right here, that the negative of that number is less than what's in the absolute value bars is less than the number. So that would have, using this, we would have -3 is less than what's in the absolute value bars, which is b plus 1, which is less than +3. Now I did that because now I've converted it into an inequality which we can actually solve for b. You can't just take away the absolute value bars. That doesn't give you a correct answer. So it's converting it into something solvable. That's why we do this. It eliminates the absolute value bars. So to solve this for b, all we need to do is subtract 1 from all 3 sides of this inequality. So we have -4 is less than b is less than 2. And there's our solution. Okay, here's another one. Now this one is different in its form in that on the left side we have both an absolute value and a number, whereas up here the left side was just simply an absolute value. So in order to use this method right here, we do have to first solve for the absolute value and get it by itself and hope that the other side is just simply a number. So in solving for this absolute value, we can subtract 5 from both sides. Subtracting 5 from both sides would give us the absolute value of 3x minus 2, is less than or equal to 9 minus 5, which is 4. And now it looks like an absolute value inequality such as above, when the absolute value is less than or equal to a number. Therefore, converting it into an inequality, we have the negative 4 is less than or equal to 3x minus 2 is less than or equal to 4. And then we solve for x. We want to isolate x in the middle. So I'll add 2 to all three sides. Negative 4 plus 2 is negative 2 is less than or equal to 3x is less than or equal to 6. Now this is positive 3, so when we divide an inequality by a positive number, the direction of the inequality signs does not change. So therefore, dividing everything by 3, we have negative 2/3 is less than or equal to x is less than or equal to 2. And there's our solution. Okay, this next one is already solved for the absolute value. That's good. We have a less than sign, so we can use the same method. And we have a number on the right. So the same method we did above will work. However, this one is a sort of a tricky problem because no matter what you do, I can tell just from looking at it that this has no solution. And that's because no absolute value will ever be less than a negative number. In fact, no absolute value will ever equal a negative number. Because when you take the absolute value of a number, you get its distance from 0, which is always a positive number. So the absolute value of 3 is positive 3, and the absolute value of negative 3 is also positive 3. Another way to think about absolute value then is that it just makes whatever's on the inside positive, that is, if you just have a number on the inside. So no matter what x is, the absolute value of any number is always going to be positive. So a positive number will never be less than negative 4. So this has no solution. Okay, now that brings us to absolute value inequalities of this form. The absolute value of x is greater than a. Okay, let's draw a picture here so you can see where this is coming from. So if you're solving an inequality of the form the absolute value of x is greater than a, then you would have something like this. Let's say that's a, that's negative a, wherever that is on the number line. Now this means the distance from 0 must be greater than a, meaning it must be further from 0 than a units away. So that would be anything greater than a would be way out here. All of these points have a distance from 0 that is greater than a. And so do all of these points out here that are less than negative a. So any x value inside the absolute value that is less than negative a or greater than positive a will solve this inequality. And that's where this comes from right here. If a is a positive number, then the absolute value of x is greater than a is an equivalent inequality to saying either x, what's in the absolute value, is less than negative a, or x in the absolute value is greater than a. And of course it's true whether you have an equal to sign there or not. So let's use this property to solve this example. It is of this form because we have the absolute value of something is greater than or equal to a number. Here we have the absolute value of a variable is greater than a number. So therefore we can convert it to this form right here in order to solve it. So we can say this is equivalent to saying either what's in the absolute value, so y plus 4, is less than negative 6, less than or equal to, because we have an equal to, or that or is very important, or what's in the absolute value, y plus 4, is greater than 6, greater than or equal to 6. Well, that gives us two inequalities to solve, and so that's exactly what we do. We just solve each inequality separately and then figure out the solution from there. So solving this first inequality for y, we subtract 4 from both sides. Negative 6 minus 4 is negative 10. And subtracting 4 from both sides over here, 6 minus 4 is 2. So now this is not our final answer right here. We need to look at this and see what this actually means in order to write our answer in the appropriate form. So this says either y can be less than or equal to negative 10 or y is greater than or equal to 2. So let's picture that and see if there's a way to simplify this set of inequalities here. Okay, so let's go from negative 10, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2. That's really all we need. Okay, if y is less than or equal to negative 10, that would be these numbers out here. Or if y is greater than or equal to 2, close circle because it could be equal, that would be these numbers out here. So these don't overlap anywhere, and because there's an or, that means any y that makes either of the two inequalities true will make this inequality true. Therefore, this is actually the solution right here, what I have circled. You could also write it in interval notation as negative infinity to negative 10 inclusive union from 2 to infinity. So both of those sets, those are two ways of writing the correct answer. And let's do another example. Now this one is not solved for the absolute value, so a little tricky. Make sure you solve for the absolute value first. By subtracting 5 from both sides, we get the absolute value of 4x plus 3 is greater than 3 minus 5 is negative 2. So let's think about this. An absolute value is greater than negative 2. Now I can actually stop right here because no matter what x is, the absolute value of any number is always going to be bigger than or equal to 0. So it'll always be positive. Okay, this will always be greater than or equal to 0. And no matter what, any number greater than or equal to 0 is always going to be greater than negative 2. Right? No matter what, any positive number will always be bigger than negative 2. Therefore, this whole statement right here is always true, no matter what x is. So therefore, our solution is from negative infinity to infinity, or all real numbers. Now let's solve it using the same process as we did above and see what we get. If we solve it using that inequality statement from above, we would have that either what's in the absolute value, 4x plus 3, let's scroll back up here, it says either that is less than the negative of this number or greater than the number. So either that is less than negative 2 or 4x plus 3 is greater than the negative of negative 2 is positive 2, or is greater than the positive of this number, which is negative 2. So solving each of these inequalities gives me 4x 2 minus 3 is less than negative 1, x is less than negative 1/4, or 4x, let's see, negative 2 minus 3 is negative 5, x is greater than negative 5/4. Now if you wrote this, that would technically be correct, but it is not in its simplified form, because let's graph these two sets here. Okay, let's see, we're in fourths. Okay, so here's 0. Let's go with 1/4, 2/4, it's 1/4, 2/4, 3/4, 4/4 is 1, 5/4 is right there. Of course, these are all negative. Okay, if x is less than negative 1/4, that would be all these numbers right here. And if x is, that's an open circle or a little parenthesis, or if x is greater than negative 5/4, that would be all of these numbers right here. And as you can see, any x that satisfies at least one of those is going to be anywhere here on the number line, meaning from negative infinity to infinity. Let's look at another example. On this one, again, the absolute value is not solved for, so first we need to do that. If we add 5 to both sides, we'll get the absolute value of x over 2 minus 3 is greater than negative 2 plus 5 would be positive 3. Now we have a greater than sign, therefore, and the absolute value is solved for, we have a positive number, this is all good. So we'll use the same method from up above that says what's in the absolute value is either less than the negative of this number, so negative 3, or what's in the absolute value is greater than the positive of that number. And solve each of these inequalities, so we get x over 2. Let's see, negative 3 plus 3 is 0, so it's less than 0, Or, well, let's keep going on this one. Multiplying both sides by 2 gives x is less than 0. Or adding 3 to both sides gives us x over 2 is greater than 6. So multiplying both sides by 2, x is greater than 12. So either x is less than 0 or greater than 12. So I can see in my head that that is not going to overlap. If a number is less than 0, there's no way it can also be greater than 12. So therefore this is a simplified form of the answer, or again in interval notation that would be from negative infinity to 0 and from 12 to infinity. Okay, and looking at one last example for this section, let's solve this absolute value equation. Where is this absolute value less than or equal to 0? This is a tricky question. Now let's first consider the part that says it's less than 0. Will the absolute value of anything, no matter what this says, whatever is in the absolute value bars, will that ever be less than 0? And of course the answer is no. This has no solutions because the absolute value is always positive. So that part has no solutions. But it could still equal 0. So to solve this, all we have to do is set what's in the absolute value, is say that this could be equal to 0. Now the absolute value of 0 is 0, so we can just take these absolute value bars away and simply solve this equation. Multiplying both sides by 5 gives me 3 times x minus 2 equals 0. Dividing both sides by 3 gives me x minus 2 equals 0, and solving for x gives us x equals 2. And now one thing I did not do on any of these was check my answers. So let's go back and check a couple, including this one. Let's check. If we plug in x equals 2 into this original inequality here, we would have absolute value of 3 times 2 minus 2 over 5. Is that less than or equal to 0? Now 2 minus 2 is equal to 0. 0 times 3 divided by 5 is 0. So yes, that's a true equation. Okay, up here, it's always a good idea to test your answer if you're not certain. So what you could do is you could plug in any number in your solution set and make sure that it makes the original inequality true. So for example, I'm going to choose -1 because -1 is less than 0. That should make this true. So let's test x equals -1. Plugging in -1, we'd have the absolute value of -1 over 2 minus 3 minus 5. Is that greater than -2? Put a little question mark there. -1/2 minus 3, that's -3/2 or -3.5. The absolute value of -3.5 is positive 3.5. And 3.5 minus 5 would be -1.5. And yes, that's a true inequality. -1.5 is greater than -2. So you can do that with any of these problems. That's it for this section. In the next section, we're going to solve systems of inequalities.